As a developer, there are many blockchains that you can learn. Ethereum is the blockchain that will give you the best return on investment for your career. Once you know Ethereum, you can leverage this knowledge for many other blockchains. In this video, I will show you how you can deploy the same smart contract on 7 different blockchains. And to do this, we only need to rely on our knowledge of Ethereum. If you don't know me, I'm Julien, and on EatTheBlocks, I teach blockchain development. Let's see the main differences when you develop a smart contract on Ethereum versus other EVM blockchains. First, let's start with some vocabulary. When you hear the expression EVM blockchain, it means a blockchain based on the Ethereum technology. The Ethereum blockchain itself is an EVM blockchain, of course, but we also have other blockchains that are EVM based, like Binance Smart Chain. But what is this acronym EVM? In the Ethereum blockchain, the part that runs smart contracts is called the Ethereum virtual machine. In input, you feed a transaction, and in output, it updates the state of the blockchain. For example, after a token transaction, the state of the blockchain will reflect that the sender address has less tokens and the recipient address has more. And for each block, we are going to give a sequence of transactions to the EVM, and between each transaction, the state of the blockchain will be updated. Another important part of the Ethereum blockchain is the API. The API allows external programs to interact with the blockchain. The two main APIs allow you to send transactions and to read the state of the blockchain, but there are many other APIs. Another part of the Ethereum blockchain is the consensus algorithm. On Ethereum, we currently use proof of work, even though we will soon move to proof of stake. When a team wants to create another blockchain based on Ethereum, they will usually create a fork of the code of the main implementation that we call geth. They will change the configuration file, which allow to configure some details like block time, the gas limit, the initial allocation of ether, etc. The consensus algorithm is sometimes changed from proof of work to proof of stake or delegated proof of stake. It can also be changed so that only designated validators can add new blocks, which make it a centralized blockchain. And for the other elements of Ethereum, especially the API and the EVM, usually they are unchanged. There is a very important nuance to understand. When we talk of Ethereum, it can mean two things. It can either mean the technology or the network. There is only one Ethereum network. That's where we have Ether and most of the DeFi projects. In this network, we use the Ethereum technology, but we can deploy this technology in other networks. That's what Binance Smart Chain did, for example. Even if it uses the same technology as Ethereum, the network is completely independent. Make sure you keep this in mind when you consider EVM blockchains. Next, I want to talk about what you need to know as a developer when you develop on EVM blockchains. In terms of development tools, it will be very similar. In Ethereum and on any EVM blockchains, you will use Solidity, Remix, Truffle, Web3, and MetaMask. Even though all these tools were originally developed for the Ethereum network, they can also be used on any EVM blockchains. What will change, however, is the configuration file of your project. When you deploy smart contracts, you have to configure the URL of a node. This URL is specific to each network. On Ethereum, you will have a specific URL, on Binance Smart Chain another one, etc. Another thing that can change is the configuration of the blockchain, especially the gas configuration. Maybe that on Ethereum, the current gas price will be high, but on Binance Smart Chain, it will be lower, etc. The block gas limit might be different too. The block gas limit is the total gas that can be spent in a single block when you add all transactions. If you want to do a giant transaction, maybe that it will work on a blockchain with a huge block gas limit, but not on another one with a lower block gas limit. Another thing that can change across EVM blockchains is the current version of the Ethereum protocol. On Ethereum mainnet, regularly there are updates to the protocol, which means that the network participants agree to modify the rule of the blockchain. This happens during forks. For example, during the summer 2021, Ethereum will go through the London hard fork that will change the way gas is calculated. It's possible that some EVM blockchains decide to not do the update and stay with an old version of Ethereum. They can also decide to do their own updates different from Ethereum mainnet. This means over time you can expect different EVM blockchains to slowly diverge and become less and less compatible. Another thing that will change is how you get testnet ether. When you develop smart contracts, you can deploy to so-called public testnets, which are networks just used for development where we manipulate fake ether. You can get this fake ether for free using websites called faucets. The last thing that can change across EVM blockchain is the integration with other smart contracts. If you deploy a smart contract that integrates with DeFi project, these DeFi projects are specific to each blockchain. You need to take this into consideration during your deployments. Okay, cool. We are done with the theory, and next we will start the coding. First, we are going to deploy on a local development blockchain. A local development blockchain is a blockchain that runs only on your computer. It doesn't matter if you make any mistake, it's completely independent from the real Ethereum blockchain. You can use a local development blockchain for any EVM blockchain, not just Ethereum. We will use a framework called Truffle. The big advantage of Truffle compared to other frameworks is that it has a lot of integrations with many EVM blockchains. So here I've prepared a Truffle project. So we have our smart contracts in the contracts folder, and in migrations, we define migration file to explain how we do our deployment. So I'm going to show you very quickly our smart contract, which is simple storage. So that's a very simple smart contract with a single variable and a function to change this variable. So the goal of this video is to show you the deployment on different blockchains. So that's why I chose a very simple smart contract. So let's exit this file. And another important file is the deployment file. So here we import our smart contract, and after we export a function, and in this function we deploy the smart contract with this line of code, and it's going to be the same exact deployment file for all the EVM blockchain. Very simple. So we exit this file, and next we are going to start our local development blockchain with Truffle develop. So here we have our blockchain running, and it has created 10 addresses that are pre-funded with 100 Ether each. And we also have the private key. And we are going to deploy our smart contract with migrate -- reset. And it's going to execute the migrations in the migration folder. First, it's going to compile our smart contract, and after it does the deployment. So there are two deployments. Here we have first initial migration. So that's a migration file that is used internally by Truffle, so you can ignore it. And after, we have our migration file deploy contract, and here is deploying simple storage, and it tells you some details about the deployment, the transaction hash, how many seconds it took, the address of the smart contract, the block number, etc. And here a very important detail is to note that for value sent and total cost, it gives you this in Ether because Truffle was first designed for Ethereum. And when you will deploy to other EVM blockchain where the native currency is not Ether, you just have to mentally replace Ether by the native currency of the network. And that's it for the local development blockchain. So if you want to exit this, you press Ctrl+C, and you are back to your terminal. Deploying to a local development blockchain is the most simple kind of deployment that you can make. Next, we're going to see something slightly more difficult. In this section, we are going to deploy to the mainnet of Ethereum. Ethereum has a market cap of 223 billion, is the number 2 on CoinMarketCap. It has the largest number of users, investors, and developers, and it has the best development tools. Next, we are going to deploy to Ethereum. So first, we are going to create an address. So for that, we can go to this website, and we go down, we click on generate, and here we select our address, we copy it in the clipboard, and we're not going to deploy to Ethereum mainnet, but instead we're going to use a public testnet because it doesn't cost any money. And when you are developing, that's what you should be doing. There are several public testnets for Ethereum. We are going to choose Goerli, and we're going to get some Goerli Ether in order to pay for the transaction fee. This Goerli Ether is not some real Ether. You cannot spend it on Ethereum mainnet, of course. This is just for development. So here it asks you to post your address on one of your social media and post the link here. So for example, I go to my Twitter and I'm going to paste the address that was just generated. I tweet this, I go to the tweet, I copy the URL, I go back to the goalie faucet, I paste this here, and I click on give me ether. So I want 1 ether. Okay. So now it's taking some time to mine the transaction. Now we have our goalie ETH, and we go back to the website to generate our address, and we're going to reveal our private key. Okay, I'm going to copy this in the clipboard, and then I'm going to the terminal, and I've already installed an npm package that allow you to send transaction to public testnet and mainnet. So we go in package.json, and so I've installed Truffle HD Wallet Provider here. And after, we're going to need to add a configuration. So we go in truffle config, and here, so we import this npm dependency HD Wallet Provider, and we need to define an array of private keys. So we just have 1 private key. Okay, let's paste this. Let's format this properly. We need to prefix it by 0x. Okay, and then we go down, and that's where we define our networks. So first, we have 2 configurations, one for Ethereum mainnet and one for the goalie testnet. So that's the one we're going to use. And the way it works is we define a provider. So we use the npm package that we installed. So we give it the array of private keys. And we also need to give it an URL to an Ethereum node. So either you run a node on your computer, but it's not very easy. Or what is way easier is to create a free account at infura.io, and that will give you an URL for goalie. So you create a project, for example, I can call it test. And then let's scroll down in settings, and in the endpoint, we can select goalie. Okay. And here we are going to select the HTTPS endpoint. Okay, so back to our configuration, and here we paste the URL. Okay, and so here we also need to add another important configuration, network ID. Each Ethereum network has its own ID, and you can find all IDs on this website. And skip dry run is not going to simulate a deployment, and it's going to allow us to go faster. So for testnet, it's good, but actually when you do this to mainnet, you better remove this option. So now we have our configuration. So we're going to save this and quit. And then we go at the root of our project, and to execute the migration, we run truffle migrate, and we specify the network. So it's ETH testnet. Also specify reset. So let's launch this. So it's going to compile our contract. Then it's going to run the migration of truffle. So it's going to take a bit more time compared to last time when we deployed to a local development blockchain. That's because this time the blockchain is not on our computer, but that's an actual network that is deployed across the world. So it takes more time to get the response from the network. And so finally, we are executing our migration, and we are deploying our simple storage smart contract. And so now we are waiting for the transaction to be mined. The deployment is successful, and we can inspect this by using a blockchain explorer. So here we have the transaction hash. So we are going to copy this in our clipboard, and we're going to the blockchain explorer of goalie. So goalie.etherscan.io, and here we're going to search for our transaction. And here it found a transaction. It was a success, and it was sent from 0x54df. And if we go back to our generator of address, we can see this is the same address. So this all makes sense. Okay, so that's it for the deployment on Ethereum. Next, we're going to deploy to another blockchain. One of the main problems of Ethereum is that its transaction fees are too expensive. Polygon is what we call an L2 scaling solution. You can consider it a sort of secondary blockchain that is attached to Ethereum. It's not independent. Polygon has a market cap of $5.2 billion. That's number 19 on CoinMarketCap. And we're going to deploy our smart contract there. This project used to be called Matic, so you will see Matic instead of Polygon in a number of their tools and documentation. We're not going to deploy to Polygon mainnet, but we're going to deploy to their testnet. So contrary to Ethereum, they only have a single testnet. And on Polygon, to pay for your transaction, you need to have some Matic token. And since we're using the testnet, we can get some free testnet Matic token. So here, this is the faucet for the testnet. And here we're going to be on the Mumbai network. And we're going to enter our address. So let's submit. Okay, so let's confirm here. So the transaction was a success. So now we do have some testnet Matic token. So next we're going to be back to our terminal and we're going to see the configuration for Matic. So for Polygon, so let's go down. And here we have the configuration for Polygon, mainnet and testnet. So it's exactly the same logic as for Ethereum. We define the same parameters. And I just realized that there is an error here in the two URLs. So let's fix this. So here, this is documentation of Polygon. And so for Matic mainnet, they have a public endpoint. So we don't need to use the URL of Infura. And for Mumbai testnet, it's this one. So let's copy this. All right. And for the network IDs, it's also not correct. So let's see, chain ID is 80,001. All right. And for mainnet is 137. Okay. All right. And we're going to deploy to this network. So let's save this. Let's go back to the terminal. And here we are going to deploy to Polygon testnet. And we specify the reset flag as well. Okay, so let's launch this and we'll see if it works. So first it compiles our contract. And we have this crazy error. So we're going to try another endpoint. So let's go back to Mumbai testnet and we're going to try this one, second one. Right, let's scroll down. All right, let's change this. Let's try to deploy again. So here we are sending the migration of truffle and it seems like this time it's going better. And now it's running our own migration. It's deploying a simple storage. So now it's waiting for the transaction to be mined. And so now the migration is complete. And here we can see the total cost. So here it's not really ETH, but it's actually Matic token. So it's much, much cheaper than on Ethereum. And so here we can see our transaction hash. So we are going to copy this. And we're going to the blockchain explorer of Matic, of Polygon, and we put the transaction hash, and we can find this transaction. It was a success. And once again, the sending address is the correct one. You can see your transaction fee here, 359, etc. And here, this is the same as what we see in the output of Truffle, 359, etc. Okay, so we are done with the deployment to Polygon. Next, we're going to continue with another L2 scaling solution of Ethereum. So in this section, we're going to deploy our smart contract to Optimism. Optimism is an EVM blockchain that is another L2 scaling solution for Ethereum. And this is one of the main competitors to Polygon. So as usual, we are now going to deploy to Optimism mainnet, but we're going to deploy to a public testnet because this is free. And there isn't directly a faucet for that testnet, but instead we need to first use the faucet of Kovan, which is a public testnet of Ethereum. And from there, we need to use a bridge to transfer this Kovan Ether to the Optimism testnet. Okay, so unfortunately the Kovan faucet didn't work. I tried some others that I found on Google, but none of them worked. So at the end, I went to the Discord server of Optimism and I found someone kind enough to send me some Kovan ETH. And next, we're going to transfer this Kovan ETH to Optimism testnet. So for that, we go to this website, MetaMask. And here, this is for the false account. Okay, next, connect. Okay, and here we're going to transfer, I don't know, 2 ETH, for example, to Optimistic Kovan. Okay, so deposit. So we approve the deposit. Okay. And we're gonna need to wait 5 minutes before we can use this Ether on Optimistic Kovan, so which is the testnet of Optimism. And finally, it will tell you that it's finalized on Optimistic Kovan with a link to their blockchain explorer. So let's go there. Okay, so let's scroll down. And here we have our address. Okay, so now what will happen? If we check our address here, we should see a balance of 2 Ether. Yes, great. So finally, we have enough to pay for the deployment. So back to the terminal. And we are going to open truffle config. And we scroll down. And here for Optimistic, so I have configured 2 networks, mainnet and testnet. We're going to deploy to testnet. And here we have they have a public endpoint. If it doesn't work, you can also try the one on Infura. Okay. So now we're gonna run this migration. Here, Optimistic testnet. And here reset. All right. And it tells me that migration hit a require or reverse statement in its constructor. So I did some research and I found out that you need to use a slightly different version of the Solidity compiler for Optimism, and you can find details in this repo. So you go to package.json, scroll down, and here this dependency. So we go to our project and we're going to install this. All right, so after back to their example repo, and we go to truffleconfig.ovm.js and we scroll down, and here in compilers we copy paste this configuration for Solidity, and here back in our terminal we go in truffle config, we go at the very bottom, and here this configuration, so we remove this, save this. I'm actually not sure which is the version of Solidity they used, so let's go in a contracts folder, for example, for Optimism, simple storage. What did they put? They put 076. So you know what? We're going to put the same version. I'm not too sure exactly what is the version of Solidity that we can use on Optimism. So we're just going to do exactly like them. And here 0706. All right. So let's save this. And we're going to run the deployment again. And this time, let's hope that it works. I realize we have an error in the configuration, so let's go up. Here's not mainnet, it's kovan.optimism.io. Okay, let's save this, and here let's run the migration again. And here what happened? Okay, so actually it did not recompile because it saw something already in the build folder. So we are going to delete the build folder to force it to recompile. So let's launch the deployment again. And here it tells us that our transaction our fee is too low and it gives us a tip. So you know what, we're gonna listen to his tip. So we go in truffle config, back to Optimism, and here let's paste this. So here this is going to be just gas for the gas limit, and for the gas price. All right, so now let's try again. And what's the problem this time? Okay, so finally I managed to make it work, and for that I had to delete the migration used internally by Truffle. So here we're going to copy the transaction hash, and we go to the blockchain explorer of Optimistic, we paste the transaction hash, and we can see that it was a success, and we can see the sending address here is correct. And so finally we made it. We managed to deploy a smart contract to Optimism. It wasn't easy, but we did make it. Next, we're going to continue with another deployment. Next, we're going to deploy our smart contract on the Binance Smart Chain. So Binance Smart Chain is another EVM blockchain. It was created by the Binance exchange. The native asset of this blockchain is the BNB token, and it has a market cap of $48 billion, and it's number 3 on CoinMarketCap, so it's really a big blockchain. And one of the big advantages of this blockchain compared to Ethereum is that it has much lower fees, but it comes at the cost of centralization. So as usual, we're not going to deploy to mainnet, but we're going to deploy to the testnet of Binance Smart Chain. So we go to the faucet to get some testnet BNB. We put our address here. We click give me BNB. Okay, so it's mining the transaction. All right. And after that, we are back to our project. So here I made some changes compared to the section on Optimism. So in the migrations folder, I put back the migration of Truffle. I also put back the version of Solidity we had initially, 0.8.6, and in truffle config, so let's go to the very bottom. And for the compilers of Solidity, here for the configuration, I put back 0.8.6, and let's go up. And so in the configuration for Binance Smart Chain, so we're going to focus on the configuration for testnet here. Binance Smart Chain offers a public URL. It's very easy to use. And okay, so let's save this, quit, and we're going to remove the build folder because we have the compilation artifact of Optimism, but we want to recompile with the normal Solidity compiler. Okay, and so next we are going to launch the migration. So it's going to be BSC testnet, and here we add the reset flag. All right, so let's start this. Okay, so it's doing the first migration of Truffle, and after it's going to do our migration. Okay, so let's copy here this migration. We go to the blockchain explorer of Binance Smart Chain. We paste our transaction hash here, and it found it. It was a success. And here the parameters make sense. It was sent from the correct address, and it's a very recent transaction. So we are done with this deployment on the Binance Smart Chain, and next we're going to continue with another blockchain. Next, we are going to deploy our smart contract on the Huobi ecochain. So this is another EVM blockchain that was created by the Huobi exchange in China. It was launched in December 2020. So its native token is the HT token. It has a market cap of $1.4 billion and is number 56 on CoinMarketCap. And for the gas fee, there are two differences with Ethereum. There are two discounts. First, they have per project discount, so you can register your dApp to their organization, and they're going to give you a discount for all the transactions passing through your smart contract. And you can also get a discount based on the number of HT token that you hold. So as usual, we are going to deploy to the testnet, and for that, we're going to use their faucet to get some testnet HT token. So here we paste our address. All right, so I'm going to verify my identity with GitHub. All right, authorized. Then how does it work? Was it sent? So for that, we're going to use the blockchain explorer of the testnet to make sure I have some HT token. So let's search for my address. No matching entry. Okay, so we're going to click on submit again here. Okay, so here, success transaction. It's being mined. So I'm guessing probably that block time must be pretty fast. Probably very soon it's going to be mined, and we're supposed to receive 0.5 HT token. Okay, so what if I refresh this? Okay, so this is a success. It was mined. Okay, great. So now back to our terminal, and let's see in truffle config. So let's go down. And so for the HECO blockchain, we have our configurations, and for testnet, it's this configuration here. And I realize here this is the wrong URL. It's this one. All right. Okay, so let's save this and let's run the migration. And this time it's going to be HECO testnet. Okay. So it's doing the migration first of truffle, then of simple storage. And that's it. So now we can verify this with the Explorer. So let's copy the transaction hash. We go back to the blockchain explorer. Let's search for this transaction hash, and they found it. It was sent from our address, and it created this contract. Great. So that's it for the HECO blockchain. And next we're going to do our last deployment. So for last deployment, it's going to be another EVM blockchain called the Kucoin community chain. It was created by the Kucoin exchange in China. It was launched in July 2021, so it's very recent. Its native token is the Kucoin token. It has a market cap of $0.7 billion. It's number 77 on CoinMarketCap. And one detail I noted about them is that they offer a public WebSocket endpoint, which can be interesting for liquidations and arbitrage. So as usual, we are going to deploy to the public testnet, and for that we need some testnet KCS token. So here we enter our address. Here I'm not a robot, the CAPTCHA, request 1 KCS. And it's going to do its magic. Come on, send me this token faucet. Okay, so you know what? It's possible that their faucet is temporarily broken. I mean, after all, it's still a very recent project. So maybe they're still setting things up. I'm still going to show you the code so that you can see how it looks like. So here, let's go to truffle config. Okay, let's go down. And here, these are the two configuration for the Kucoin chain. And so for the testnet is this one. And here they have a public endpoint, so it's easy to use. And if the faucet was working, basically to deploy here, all we'll have to do would be to run network KCC testnet, and that's it for the Kucoin blockchain. As you can see in this video, it's very easy to leverage your Ethereum skills for other blockchains. We use the same development tools, and we only had to change a configuration file for the deployment. And what I showed you is just a small part of all blockchains based on Ethereum. If you want the full list, you can check out this website. Even though you have all these EVM blockchains, the three that matters the most are Ethereum, Binance Smart Chain, and Polygon. All the other ones are far behind in terms of popularity. When you search for tutorials, because everything is based on Ethereum, I recommend to use the keyword Ethereum. For example, even if you want to learn how to create a smart contract on Kucoin community chain, no need to include the Kucoin keyword in your search. You will find way more resources if you search something like how to create smart contracts on Ethereum. And on my channel, I have many tutorials on Ethereum. And what I recommend is to continue with my playlist on Solidity. I will see you there.